Students, in this session, we are going to see what is the force experienced by a charge moving in a magnetic field. You know, when an electric charge is kept in an electric field, it will experience electrical force. And the electrical force is given by F is equal to E. This is the force experienced by an electric charge kept in an electric field. So electrical force is equal to electric field into charge. And similarly, when a magnetic pole is kept in the magnetic field, it will experience a force. So F is equal to B into Qm. So it is the product of magnetic field into pole strength of the magnet. So when a magnetic pole is kept in magnetic field, it will experience a force, that is magnetic force. When an electric charge is kept in an electric field, it will experience electrical force, EQ. Here what we are going to see, when an electric charge is moving in a magnetic field. So when an electric charge is kept in a magnetic field, it will not experience any force. But at the same time, when an electric charge moves in a magnetic field, it will experience a force. So the expression for the force experienced by a charge moving in a magnetic field is obtained by Lorentz. And hence, this force experienced by a charge moving in a magnetic field is called as magnetic Lorentz force. So let us consider a magnetic field. So this is magnetic field. It is acting along the z-axis. We are considering a charge. Let this charge moves with the velocity v. Let v be the velocity of the charge. It moves with the velocity v. When it moves with the velocity v, this charge, let q be the charge. This charge will experience a force, and this force will be perpendicular to the magnetic field at velocity. This force experienced by a charge moves in a magnetic field is called as magnetic Lorentz force. So Lorentz found that this force is directly proportional to the magnetic field. This force is directly proportional to the velocity with which the charge is moving. This force is directly proportional to the amount of charge. And this force is proportional to the sine of the angle between the charge and the velocity. So, combining all this, we can write this magnetic Lorentz force is BQV sine theta. Or I can say F is equal to constant of proportionality takes the value 1. So F is equal to BQV sine theta. So here Q is a constant, not a vector. It has only magnitude. But velocity and the magnetic field are vectors. Product of two vectors yield a vector. So it can be written in vector form. So in vector form, F vector is equal to Q into V cross V. V vector cross V vector. So this is the vector form of magnetic Lorentz force. So the direction of the magnetic Lorentz force is obtained by Fleming's right hand rule. So what is the Fleming's right hand rule states that stretch your forefinger, middle finger and the thumb mutually perpendicular to each other. So the Forefinger represents the direction of the magnetic field. The middle finger represents the direction in which the charge is moving. The thumb will give the direction of the force. So, magnetic Lorentz force is given by F is equal to Q into V cross B. So, when a charge moves in a magnetic field, it will experience a force. Due to this force, the charge will have a motion. So, what type of motion a charge will have when it moves in a magnetic field? So, when you see this force is always perpendicular to the plane containing magnetic field and velocity vector. So, since it is always perpendicular, this force will not produce any change in the velocity. So, any force which do not produce any change in the velocity, but it produces change in the direction of the velocity. So, velocity changes, but not in its magnitude, but its direction. So, it continuously acts on the charge and produces change in velocity, not in magnitude, only in direction. Such a force is called as centripetal force. So, when a charge moves in a magnetic field, the magnetic Lorentz force which acts on the charge acts as a centripetal force, and once this charge is acted upon by centripetal force, it will have circular motion. So, this charge will begins to move in a circular motion. So, when a charge moves in a magnetic field, it will experience magnetic Lorentz force. This magnetic Lorentz force provide necessary centripetal force for the charge and makes the charge to move in a circular motion. So, whenever a charge moves in a magnetic field, the type of motion the charge will have is circular motion.